Good morning, everyone. We got a launch. We got a Euclid today launching. How's everybody doing? Everybody doing okay? You call this music a question? You still waking up? Come on, you need the coffee. You need the coffee. All right, so today we got the Euclid telescope launching on Falcon 9. Now, what's Euclid? And well, it's named after a Greek mathematician, right? And who invented geometry. Well, not invented, invented. I don't know. Came up with the construct for geometry. Something about, probably about, I don't know, 2,300 years ago and change. Give or take. Hey, Diamond, what's going on? So, what does Euclid do, and why is it named after him? Well, it's basically designed to study the geometry of the universe, particularly in the form of dark energy. Now, I needed to learn what the heck dark energy means. Because you say that to me, and I'm thinking there's Siths afoot. So I had to go and do a little bit of reading. I'm taking this right from the ESA website, but here's the thing. Euclid is designed to explore the evolution of the dark universe. It will make a 3D map of the universe with time as a third dimension by observing billions of galaxies out to 10 billion light years across more than a third of the sky. While dark energy accelerates the expansion of the universe and dark matter governs the growth of cosmic structures, scientists remain unsure about what dark energy and dark matter actually are. By observing the universe evolving over the past 10 billion years, Euclid will reveal how it's expanded and how structure is formed over cosmic history. And from this, astronomers can infer the properties of dark energy, dark matter, and gravity to reveal more about their precise nature. Those were some words. Hey, Vasi, what's going on? Geometry is what led to Quackulus. Yep. Hey, Wildland, 80-month resub. Thank you very much. So, that's pretty cool. That's pretty sweet. A little bit of a background on this. This mission was supposed to fly on a Soyuz out of Kourou, but it's not going to do that. Is Mike picking up some air conditioner sound or something? Yes. Yeah, I have the AC on. It's been really, really hot. Not today, Aquex. It's my day off. it's my day off. I got stuff to do after this, but I did find some time today. Freaking been up for a little while. All right, just to be sure it's not some static. No, it's the AC. Yeah, I'm out in a shed, in a metal shed in my backyard. Big metal shed, but it's a metal shed. So yeah, it gets pretty hot in here. It fits because it's like a server room. All right, cool. Yeah, no, it's the ambient. Thank you. All right, so this was supposed to launch on a Soyuz, but due to current geopolitical situations, it's not. It was moved to a Falcon 9. So it, and actually a lot of other European Space Agency missions that they had lined up for other launch vehicles are going to end up going on SpaceX rockets, and this is the first of a couple of those things. What color is your roof? Beige-ish? Beige-ish? Maybe? Anyway. So, yeah, that coverage should be popping up here very soon. Let's see. Why not brown? So NSF is up and running. They just It just popped up. There's a shot here. There we go. So the Euclid telescope's in this part up here. That's Falcon 9 sitting on the launch pad. That's Complex 40 if I'm looking. Oh, it says it right there. Nice! Man needs a better mic, chat. Brimo's convinced herself of this. So, right there, you see Falcon 9. You can't really see the second and first stage here because they're blocked by the transporter erector. This truss structure here is basically what they build the rocket on. And that truss structure actually folds down. It would fold down towards us this way and actually goes inside of this hangar right here. It's funny because the payload is actually transported vertically, right? They move the fairing vertically on a truck, and then they take the fairing and they attach it to the rocket, which is on the TE. And it's funny because you have fairing-shaped doors right there. The door is the exact size of the fairing. And the truck with the fairing goes in there, and in this part of the building, they rotate the fairing and attach it to the rocket. Then the rocket rolls out, and they turn it upright. It's pretty cool. I know I always get asked this. What are these things? Lightning rods. You don't want this to get struck by lightning. It has explosions. It has explosions. I should say potential explosions inside. You don't want that getting hit by lightning. So down in Florida, where it does thunder and lightning a lot, they have lightning rods. I was thinking about one of the Aging Wheels video where he painted his workshop's roof with a white insulation, and it helped a lot. Hulkenberg? Glendale. Nice. Drummer. I thought the Russian space guys... Well, these were... Yeah, Vin, it was the last guy that did that, and the new guy hasn't bothered to do anything with that, but it's alright. Hey, Moves, what's going on? So we're about 35 minutes out here, and we'll switch over to the regular SpaceX cast. But yeah, in the meantime, we have permission to restream NSF, which is pretty dope. That's pretty neat.
Discovery, go at throttle up.
Glendale, 7 months. Thanks, buddy. All right. Okay. 7 months is kind of sad seeing how long you've been coming here. Yeah, whatever, dude. It's all good. Is the NSF stream in the best quality? Kind of looks pixelated. Drummer, this shot's probably... So this is on the ITL causeway, judging by the angle of the camera. Here, let me show you. Let me show you where this shot is. How many Falcon 9 boosters can fit in that hangar? Space videography, that's a good question. Pretty much one. The integration hangars, they're called horizontal integration facilities. They can't really hold much. Here, that's the shot of that building right there. You can see that's where that's the payload fairing doors, like I was telling you about. And basically that building, it has enough space for just the rocket and the transporter erector and the payload, and that's it. Basically, think about this be like if I was about to make a baseball reference, but I'm not really sure how many people are going to get it, but I'll do it anyway. This is the batter's box. That's the on-deck circle. All right, so the only rockets that come in here are rockets that are getting ready to launch. Now, where does SpaceX store them? Well, They do payload integration inside of this building here. That's the clean room. Basically, that's where they put the payloads inside of the fairings. And they store boosters in a couple of different spots. But the big one is actually right here. That's where they do all the storage. Hey, Gil. How was your time away? Hope you have a lot of memories and rest. Dude, I'm doing just fine. EJ, tell Elon to stop launching on the weekend so you could have your days off. I made sure I got my stuff done. So yeah, they store them in here. This is basically the dugout. There's a bunch of Falcon 9s in here. If you could look, there's a bunch of doors there, and they actually expanded it. There is a bunch of stuff hanging out in here. This is next to SpaceX's future Starship facilities over here. You can see the Starship towers being constructed right there. These pictures actually updated, which is actually pretty sweet. April 30th, 2023 is when these were taken. Recently I started playing City Skylines again, and now I'm seeing it everywhere. Yeah.
Discovery, go at throttle.
How do they lift the rocket once the payload is attached? Is that not heavy? Oh, absolutely. Oh, yes. Integration questions. Latte, you're making my day, dude. These are my favorite questions. All right, here. Let me go into my Falcon Research Pictures folder. So, Falcon 9 moves on a transporter erector, okay? See the white piece is the TE. Actually, the transporter erector makes up a couple of different components. There's the erector piece, right, which is this, the erector and strong back, and then there's this gray piece. The gray piece is called an RF, or reaction frame. That's what SpaceX calls it. So, how does this whole thing work? All right, so how they now keep in mind, this is the one at pad 39A. This is 39A's TE, but the one at 40 basically works the same way. It's the same idea, right? So how do they do this? They don't lift the rocket up with payload on board. So how they do this is they attach the second stage to the first stage before this thing is even on the transporter. And if you notice right here, there's a holder. There's like a cradle right there on the transporter erector strongback, right? There's a cradle right there. And if you notice, that cradle is on hydraulics. So basically, that thing can kind of pivot upright. Actually, it goes this way. It can pivot up and down like this, if you look right there. So basically what this does is they take Falcon 9, and Falcon 9 can actually hold the second stage on board, on the first stage, without actually, with no extra structural bracing, which is actually kind of nuts. Here, I have another picture showing that off. I gotta find it though. So, yeah, see, the first stage can carry the second stage, no problem. Though, believe it or not, this is the heaviest part, aside from the payload, right? I'm trying to find, I have a picture somewhere of them moving around a first and second stage by themselves. Raptor Christmas tree. Anyway, so basically they'll attach the first stage to the second stage. These are all really nice pictures though. There we go, like that. They'll put those two together, and then they put it on the TE. So how do they do that? The first thing that they bolt down is one of the hold down points. So the crane kind of fits, actually it would be reversed. So it kind of fits the rocket in like this, and then that holder piece that I was telling you about kind of cradles it, and they move it down, and they set the thing down on the strongback. Now, once again, I want to show you, that is holding up the inner stage right there for Falcon 9, and that and the clamp arms up here are the only thing that touches the rocket from the strongback. Yeah, the rocket is basically clamped right here. There's no clamp on that. That's just a holder. It's just a cradle, right? So they clamp the second stage, right? That's sitting on the cradle, and then 4 hold down points are holding the thing in place. So they move it like they put it on the transporter erector like this. Now, when they go to integrate payload, depending on what it is, they pick it up with a crane, and SpaceX has these integration gantries right here that are designed to do a couple of different things. Now, the very top of the transporter erector, when is the launch? Toby, we're looking at about 25 minutes. Probably a little less. 27 minutes. Now, there's a picture of them before they put the second and first stage together. But hey, JuiceBot, what's up, man? 53-month resub. You put the rocket on the thing and give it the big tippy. That's it. Well said, Shach. Well said. So what are those? Looks like cables off the right side of the image. Let me go back to that shot. These are lightning. That's a lightning cable. These are attached to the... No, yeah, maybe they're attached to the tower. I'm not sure what these two are. I know what those ones are. Those are the slide wire baskets. In case somebody has to get away from the tower. I could talk more about slide wire baskets in a moment. But basically... yeah, they are. They're the lightning rod cables. See them over there? So basically, if lightning hits the lightning rod at 39A on the tower, the lightning will shoot down here and ground out. Oops. Nice shots, man. All right, so the integration table. I'm not exactly sure what this thing is called, but there's two types of them. There's one for putting Dragon together, and then there's one for putting fairing on top. Now, the interesting thing, and this is what started this discussion here, the 40 hangar can't really hold another rocket. The 39A integration facility, you can see from this picture, it can hold more. Does anybody know why? Why would it be able to store more booster cores inside of it? I mean, obviously you want more parking spots, right? There's another reason. Ugh! There's another reason, though. I'll give you a hint. It's on the screen.
Discovery, go and
they need to
drop
be able to put a heavy booster together. You got to get 3 boosters teed up in there, and then put that on there. That's why it can hold more, because it needs to be able to launch heavy. And there is them picking up a fairing. So the fairing comes in vertically, and then they pick it up with a gantry crane, right? And they have a bracket that holds the end, and a bracket that holds the fairing on its center of mass. And they basically take the crane, pick it up from one side, tilt it, or no, they do the opposite of that. They pick it up, and then the crane attaches. They have one crane that goes down, attaches to the side, and they rotate it, and then they put that on the rocket. Now, the cool thing is that that's Vandenberg. Hold on. The cool thing is that not a lot of people know the top of the transporter erector and strongback. See how it attaches here, 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 and here? It's not just one solid piece. That's actually configurable. You can configure these things. Depending on if you're launching Dragon, there's the Dragon transporter erector attachment piece, or if you're launching Falcon with just a regular cargo fairing. Yeah, there's another shot. See? It's configurable. They'll actually take this thing apart. They'll take this piece off, and they have the one for fairings in there too. The fairing one is actually a little bit different. Now, why is it a little different? It's a little different because it has like a holder cradle, an additional holder on it that cradles the fairing and the second stage. Actually, hang on, let me go back to that picture. There it is. See? This basically gigantic ratchet strap holds the fairing, but you could see that it's in the retracted position here. They'll move this thing out of the way, and this thing will pivot on those mounts, and it'll pivot back into place, and it actually kind of just holds the fairing so it doesn't fall over. Okay, in that photo, what's actually providing the force to lift it? The photo where it was like halfway up. So we talking about getting the rocket vertical? I have a picture of one that's halfway through the transport. Here, I gotta find it. I know the picture you're talking about. I have a lot of really good Falcon 9 pictures. I save them for these exact moments when I have to explain how all this works. This is it's a research folder. It's for research purposes. I gotta find the one of it tilted. Right here. Okay. So, big honking hydraulics. Yeah, big hydraulics. The big boy hydraulics. Now, you got to keep in mind, you know, why is the hydraulic all the way over here? This is a bunch of extra stuff. Well, the heaviest part is down here. The heaviest part is the hold down points. So believe it or not, that's basically on the center of mass of this thing. Because that reaction frame, the gray part at the bottom, the part that holds the rocket, it's built pretty strong for pretty obvious reasons. Yeah, that ends up making this part really super freaking heavy, and the center of mass is actually low. Yeah, see him right there? Big boy hydraulics. Looks more like a trebuchet. Yeah, kind of. Yeah, the one at 39A is beefed up because Falcon Heavy, it actually has 4. See him right there? Those hydraulic rams are gigantic, dude. And they're basically mounted in the flame trench. But 39A has a deflector that's going to deflect. Those are basically a bar. That's not the actual hydraulics. This one. They're down in the flame trench, but there's a deflector that shoots the flames that way, so flames don't go into your hydraulics. But yeah, see that? They're gigantic. The crazy part about this is that, look, if you want to get good moment over a fulcrum, right? So your pivot point is right here. You can see where the thing is pivoting on the pad. See the bolt? That's the hinge right there. If the hydraulics is pushing here and that's pushing there, can you imagine where the center of mass of this thing actually is? Think about that for a second. If the center of mass was out here and you went to push on it with the hydraulics, the thing would want to go that way. It would want to go that way, right? Where the hydraulics are pushing, they're either pushing on the center of mass of the combined pivot here, or they're pushing in front of it. Like, i.e. the center of mass is somewhere over here on this entire thing. Look at how close it is to your pivot point. Crazy, right? Anyway, SpaceX seems to be going live here, so let's see what's going on. Whoop. Thank you, Nick. What's responsible for all that weight? The engines have a lot to do with it, Latte, but it's mostly that the pad is heavy. But it's like that on purpose. It has to be heavy duty. It holds the rocket down. It has to be strong. So yeah, the center of mass is very biased towards the bottom of the rocket. And that, when the rocket is flying, that's the case. The engines are by far and away the most mass dense component on the vehicle, save for probably fuel and oxidizer.
Discovery, go at throttle up.
Most people really don't have any sort of intuition how much force hydraulic cylinders can make. I mean, they can lift up cars, no problem, Tabak, if that's any consolation. Hey, Hidgy. 80-month resub. Well, hi. Hello. Seriously, where else can you go to learn such stuff? I got you, man. I got you. Cool, so what about the cables? I think you called them slide wires. Yeah, sure, I got you. So the slide wires are part of an emergency egress system. So see these things? They're slide wire baskets. If something goes absurdly wrong and the crew needs to get off of this, get away from this thing really, really quickly, they can egress out of the vehicle. They run down the crew access arm and they run over here. These slide wire baskets are basically on a zip line. And if you run, you're not going to sit there and take the elevator if there's a fire on the pad, right? You're not going to sit there, you're not going to take the elevator, and you definitely ain't taking the stairs if there's a fire down there somewhere, right? So what they'll do is they'll run in here, jump into a slide wire basket and hit a button, and the button will detach the slide wire basket from the tower, and they can get away from the pad quick. It's part of an emergency egress system. You can see it over there. Now, the cool thing is, for the people that like a little bit of spaceflight history, those are the slide wire baskets left over from the shuttle program. But for the shuttle, they were mounted down here. Back in like 2017, 2018, SpaceX literally detached the slide wire basket mechanism with a crane and just moved it up here and bolted it back up there, which is actually pretty cool. Yeah, it's a slide wire. You can see the egress slide wires right there. Most pads that have crew launches in the US have this. Actually, all of them do. Yep. Does the telescope have an emergency rope too? No. See, there's your lightning rod wires right there, and then there's the egress wires. You can barely see them, but they're there. All right, here we go.
My name is Jessie Anderson, and I'm an Integration and Test Engineering Manager here at SpaceX. And today we have a really cool payload on board the second stage.
So we got
We're
Euclid.
sending a space telescope for the European Space Agency to a Sun-Earth L2 transfer orbit, also known as the Sun-Earth Lagrange Point 2, which is nearly 1 million miles beyond Earth's orbit. This telescope's mission is to help answer the question...
Stage 2 LOX float has started.
To help answer the question, what is the universe made of, by exploring the cosmic mysteries of dark matter and dark energy. It will create an unmatched 3D map of the universe by observing billions of galaxies across 10 billion years of cosmic time across more than a third of the sky. The mission today was named after Greek mathematician and founder of geometry Euclid of Alexandria, and since the density of matter and energy are linked to the geometry of the universe, the mission was named in his honor. The spacecraft today was built by the European Space Agency, or ESA, with contributions from the Euclid Consortium and NASA. In fact, over 3,500 people from 21 different countries were involved in making today's mission possible. After launch, Euclid will have a month-long commissioning phase while traveling to its final destination. After 2 months of performance verification, it will then be ready for its science operations to begin. ESA will need some time to process the data, but is anticipating sharing the first images with the public in the fall. In just a few minutes, we'll be joined by members of the ESA team to talk more about the mission, so stay tuned. At T-minus 15 minutes and counting, we're well into propellant loading on the vehicle. Both the rocket and spacecraft are healthy.
So actually, Latte, if you're still here, you want to see something cool, they'll probably end up putting slide wires on pad 40 too. If you guys notice right here, that's the start of a crew access arm. They're going to build a service tower here so they can do crewed launches from pad 40. Yeah, that's what that foundation was on the right-hand side of the rocket in this picture. SpaceX is actually preparing pad 40 for crew launches as well. Yep. And that'll put the count for crew-capable launch pads at the Cape at the highest it's ever been, ever. Pad 41, Pad 40, 39A, and 39B will all have crew access towers. And then in the future, we might see a crew access tower at Slick 36 too. So that could put us up to 5 human-rated rocket architectures all launching from the Cape, which is actually really, well, not 5. They're not 5 different architectures, but you get the idea. 5 crew-rated launch pads, which is actually really impressive. There's never been that many before, which is cool. Did they build it in the States or they boated it across? They boated it across, most likely. It's the Earth-Sun L2 point. Earth-Sun L2, 1D, if you guys want to know. I think that's where James Webb is, if I'm remembering correctly. It is a neutral point in gravitational space. So, what does that mean? There are kind of... The best way that I can... When will this be ready? I don't know. It's gonna take a second, Chris. But see, they got their safety railings down there. See that? Just like I do, see? It's like Satisfactory builds, baby. No, it's all good, man. Don't worry about it. Slick 36, I'm not sure. Blue Origin doesn't like to tell us anything. What's my favorite launch location? The Cape, dude. Of course. Um, 36, Creeper. Wasn't Webb L3? Yeah, okay, so Lagrangian points. Lagrangian points are neutral points in gravity in space. So the best way I can describe it is that there are tide pools in space where the gravitational pull of 2 planets or 2 celestial bodies actually cancel each other out. So there's kind of just like a little tide pool of gravity, and you can actually kind of sit there and you could sit in that tide pool. James Webb is at a Lagrangian point. And this satellite will be going to those Lagrangian points too. Now, why? Why would we put a satellite there? Well, here. That's a good visualization here. So, this satellite is going to, time to wake up, is going to an Earth-Sun L2 transfer point. So, see where that L2 is? They're neutral points in gravitational space. The grav well is visualized here as this, well, right? And there are certain points where the gravitational pull of both planets or both celestial bodies cancel each other out. Now, why would you want to put one at L2? Well, if you're going to Earth-Sun L2, the Earth is constantly, in this neutral point in gravity, the Earth is constantly blocking out the sun. And it's better to do astronomy at night. But when you're up in space, there's no nighttime. Unless you're close to a planet, there's no nighttime. So you want to be in a spot where the sun is getting blocked. And that Earth Solar L2, right? That's a good place for a space telescope because you're perpetually eclipsed. That's why they do that. Pretty smart, right? Now, with that being said, Euclid also has a gigantic sun shield on one side. See that? That's what this thing is. It's designed to keep the heat away from the telescope. Why? Well, heat distorts light. Pretty straightforward. Yeah, see, there you go.
More than 1/3 of the sky. Producing record quantities of data, Euclid will enable scientists to draw a precise map of the universe across space and time. This will allow researchers to investigate the effects of dark matter and dark energy on the apparent shape of galaxies and on their motion and distribution over immense distances. In turn, this will help reveal the true nature of dark matter and dark energy. The spacecraft and data communications will be controlled from ESA's European Space Operations Centre in Darmstadt. To cope with the vast amounts of data Euclid will acquire, ESA's ESTRAC network of deep space antennas has been upgraded. These data will be analysed by the Euclid Consortium, a group of more than 2,000 scientists from more than 300 institutes across Europe, the US, Canada and Japan. Understanding the elusive nature of the universe has drawn astronomers throughout history. It remains one of the most challenging investigations in modern science.
Forlorn, how are you?
But Euclid is up to the task.
Thank you for the bits.
The Euclid mission is a quest into the unknown. A mission to shine a light on the dark side of the universe.
Give me that synth arpeggio back. That was sweet.
Euclid is SpaceX's first mission to a Sun-Earth L2 transfer orbit, also known as the Sun-Earth Lagrange Point 2. The Sun-Earth L2 transfer orbit is nearly 1 million miles beyond Earth's orbit and a most ideal orbit for space-based astronomy because telescopes in this orbit, like the James Webb Telescope, can keep the Sun, Earth, and Moon behind them while being close enough to transmit large amounts of data to Earth and receive solar power from the Sun. Now, in order to get the rocket and payload into any orbit, the rocket has to not only go up really fast, but it also has to go sideways. As we ascend, we tilt the engines, and that turns the rocket horizontally. To help demonstrate this concept, imagine firing a cannon from a really high mountain. The cannonball will arc, and then good old gravity will pull it back down to Earth. As you increase the power, the cannonball will arc and land farther and farther away. Eventually, if you could continue to increase the power, the cannonball will end up in free fall around the Earth. Basically, gravity is pulling down on the cannonball, but it's going so fast that it never hits the ground. This arc that constantly misses the Earth is called an orbit. Falcon 9 effectively does the same thing as the cannon in this example. It provides enough power and horizontal velocity to the spacecraft on board the second stage that the spacecraft is placed in orbit around the Earth. You'll be able to see this today by watching the orientation of Falcon 9 after...
Okay, that was... All right. Anyway, can only one satellite occupy L space? No. In soccer, that's why I call it kind of like a tide pool. Because that neutral point in gravity is... You can't, like, kind of sit right in the center of it. Believe it or not, you orbit around it. Yeah, you orbit or you get stuck in the tide pool. That's why I use that. That's why I use that analogy to describe it that way. Satellites actually orbit around Lagrangian points. They're stuck in the tide pool. So you can have more than one satellite out at L2. James Webb is out there right now. And Euclid will join it very soon.
Falcon 9 rocket right off the launch pad behind us. As you said, joining me this morning is Joseph Aschbacher, the Director General of the European Space Agency. Good to have you here this morning.
Glad to be here every time.
Yeah, I love that you're here. And yeah, just talk to us about how Euclid's launched that we're about to see in a few minutes. Comes on the heel of a great year for you guys at ESA.
ESA had really a fantastic year. We just came out of a ministerial conference in November last year, plus 17% more budget, many new projects, many new activities, so quite fascinating. We have selected 17 astronauts. Some of them will fly from here into space. We have just signed an agreement with Axiom. We're having 5 astronauts in training right now at the Astronaut Center. We have launched JUICE earlier this year. JUICE is an amazing mission which fits very well with Euclid, which is looking at habitability of the icy moons of Jupiter, something quite unimaginable, just as crazy as Euclid, dark matter, dark energy, which is really amazing. So we have a lot to do. We have a Space Summit coming up towards the end of the year, where we want to raise the profile of space in Europe to top-level politicians and to see what Europe needs to do to really be a strong space power, also to our partners in America.
Right, and in order to foster that, the space industry, I mean, one of the reasons you really want to do that is to also address a global issue that we here at NASA really care about as well.
Oh yes, we do. We have many satellites that look at our planet. Climate change is the largest problem on our planet for many decades to come, if not centuries, and we need to do everything we can from space. We have the Copernicus program, we have Meteor program, we have just launched MDG-1 last year, fantastic images that just came out, and we really make sure that we use our space assets to the best of humankind, and climate change is one of our big concerns. And one element which we just launched is not only on ground that we want to see at climate change, also in space. And I'm about to really initiate a zero debris charter where we would like to encourage people worldwide to not pollute our orbits. That means if you put a satellite up, you put it down at the end of its lifetime, and that's a new initiative we are doing.
Great. And any words for all the scientists that are hoping to really learn a lot from this Euclid mission?
Oh, the incredible science will come out. I'm pretty sure some Nobel Prizes will be won based on this data. This is really a fascinating mission. I'm so happy. I thank my community, my member states, industry, NASA also as a partner, and all the contributors to this. And thank you so much for this contribution.
Well, congrats to you, and I can't wait to see Euclid launch.
Thank you.
Thank you so much.
All right, guys. So what I'm going to do here is I'm going to run ads so you don't get ads during the cast. I'm going to run the ads so nobody pops into the stream and gets a pre-roll right when the rocket's going to launch. So yeah, I'm not really a fan of doing that, but also, you know, I don't want people to see a thumbnail of a rocket launching, right? Click on it and then see a freaking ad for something they don't need. You know what I'm saying?
Discovery, go at throttle up.
Frick those ads. Yeah. Hey, Hooch, 8-month resub. Yeah, I was mistaken about the eclipse thing. I was thinking of another orbit. I was thinking of the Earth-Moon. Excuse me. Yeah, it can actually get solar out there. The Earth isn't totally eclipsing it. It's too far away to do that. That is my fault. My bad.
Discovery, go at throttle up.
Florandrius, 21 months. Thank you. Bad typo, Hellfish. Bad.
Side of T-2 seconds, we light the Merlin 1D engines for liftoff. The Euclid payload continues to be healthy, and the Falcon 9 team is tracking no issues on the rocket. Currently, both the vehicle and payload are healthy.
Stage 1 LOX flood is complete.
And we're looking good for an on-time liftoff at 11:12 a.m.
Yeah, there you
Eastern
go.
time. So let's send it back to Megan over there in Florida.
What direction should I look from the Florida Gulf Coast? East?
are waiting to watch the Euclid spacecraft launch atop of Falcon 9, again, on the launch pad right behind us. So with me now is Carol Mundell. She is ESA's Director of Science. Really great to have you here today.
Hi, Megan. Great to join you.
So talk to me about why studying dark matter, dark energy, why is that so important to understanding our universe?
Yeah, sure. This is one of the biggest unsolved problems in modern physics. So we actually think we understand only 5% of the universe, with the matter that we see, galaxies, stars, planets, ourselves. So 95% of the universe, dark matter and dark energy, is still a mystery and enigma, a huge frontier of modern physics that we hope this mission will actually help to push forward.
So then how do you go about detecting things we can't see?
That's a great question, and of course this sense of darkness really comes from the fact that dark matter does exert gravitational pull, so we see the effect of it. We look at galaxies and they spin too quickly for the number of stars and the amount of gas they have. We look at the clusters of galaxies in the universe and we see too much mass. And so we don't know what fills that mass. It might be exotic particles, it might be that we've got our equations wrong. And on top of that, our universe is expanding. But the really big mystery for modern physics is that that expansion is accelerating. So it's actually getting faster and we don't know why. Our equations don't tell the whole story. And so what this mission will do is it will map all of that out to 10 billion years back in history and hopefully tell us the answer to the mystery of life, the universe and everything.
So then really quick, when do we expect to get this data back to start really analyzing it?
Yeah, so this is a 6-year mission, and the first 3 months of the mission will actually be calibrating the data because this is a huge feat of engineering technology. We have very, very precise images across all of the extragalactic sky, and then scientists around the world, we have 2,500 scientists in Europe and in the US across 9 data centers, will analyze these data all the way through 6 years. So our final cosmology answers will come at the end of the 6 years, but we'll do lots of exciting science along the way as well.
Carol, thank you so much. Very exciting.
Thank you.
Thanks, Megan.
They were telling her to go faster.
Thanks,
Could you
Megan.
see how she started talking really fast at the end?
We are just under 1 minute. Falcon 9 isn't
They're
started,
like, wrap it
and
up!
we're just waiting for the
Wrap it
final
up!
go for launch.
All right.
LD, go for launch.
Launch director is reporting
And
go.
great news. All systems are go for launch of Falcon 9 and ESA's Euclid Space Telescope.
$30 seconds. There's
T-minus
the
30 seconds and counting.
TE purge. What they're doing is getting all the oxidizer out of the fuel lines that go up that transporter erector to fuel up the second stage. That vent is to make sure that the fuel is basically in the rocket and not in the launch pad. You don't want it in the launch pad when it launches. That could catch on fire.
T-minus 10, 9, 8,
Here we go.
7, 6,
Sound suppressor is
5,
on.
4, 3,
Ignition.
2, 1. Ignition. Liftoff.
Oh, wow. That took a second to get going, but we got a lift. That's a heavy satellite.
Vehicle pitching downrange.
All right, that looked good. That took a second, though. You see it kind of, it's like, oh, okay, this is heavy. The thrust to weight ratio was a little bit down there. But that's as expected. Okay, we should get a power and telemetry call here in the next 15 seconds.
Falcon 9 has
Roll program.
successfully lifted off from pad 40 and throttled down to prepare for
mark.
max Q, which is coming up at T plus 1 minute.
Power and telemetry nominal.
1 minute and about 12 seconds. Max Q is the highest amount of aerodynamic pressures. That's the largest structural load that the vehicle will see on ascent. We throttle down those engines just to pass through max Q, and then we'll throttle them back up once we pass through that period.
So maximum dynamic
Falcon
pressure.
9 is supersonic.
There we go. Maximum dynamic pressure is the period in which the rocket is ascending through the atmosphere where it can't move the air out of the way fast enough. So it's basically diminishing your turn trying to push against all that air that gets compressed
Maximum dynamic pressure.
up on the front of the fairing. So they throttle the engines
Great
down.
news. We have passed through max Q.
A little windy
Getting
up
some
there today.
excellent views there on your screen. Next up, we have a few
Look,
events
you can
happening
see 39A
back to
and
back. That will be
39B over there,
MECO, stage
and the shuttle
separation,
landing
and
runway right
SES-1. MECO is main engine cutoff, and that's where
Thanks.
we'll shut down all 9 of the M1D engines to slow the vehicle down in preparation for its next event, which is
MVAC chill has started.
stage separation. And that's where the first stage separates from the second stage, right after.
Okay, so they call them vac chill, meaning what they've started to do is prime the second stage engine with fuel and oxidizer. So when the staging actually happens, they have basically the engine's ready to go. Now, on top of just priming it to make sure that it has fuel in it, you don't want to dry fire your rocket engine. That won't end well at all. They're also thermally conditioning the engine because Falcon 9 is using liquid oxygen, and liquid oxygen's super freaking cold. You don't want to shoot that right into a warm-ish rocket engine. So they're trickling the propellants in during the chill down to make sure that the engine is primed and make sure that it's at the right operating temperature.
Again, coming up, we have MECO, stage separation, and SES-1.
Okay.
Main engine cutoff.
Watch, you'll see a little puff right there. All right, there's main engine cutoff. Stand by for staging.
Stage separation confirmed.
Got a good stage. Hopper stage ignition.
MVAC ignition.
Looking good. You can see all the coast of freaking the Cape right there. Look, you can see all the way down to Satellite Beach.
Some really cool views of MECO stage separation. And on your right-hand screen, you can see that the MVAC engine has ignited.
Vehicles are following nominal trajectories.
Dude, this shot is
on your left-hand
really
screen,
crisp,
the grid fins
right?
on the first stage are deploying.
Holy cow.
And in about 15 seconds or so, we should have fairing separation.
This is definitely a higher resolution camera. So right there, that's the first stage.
And a very cool view from the ground.
Stage. When the fairing deploys, you'll see them pop off the sides here. This is a shot from freaking down on the ground. The thing's over 100 kilometers away.
Confirmed.
There goes the fairing. Fairing is the
and
aerodynamic
there you can see on your
shell.
right-hand screen that the fairing halves have deployed.
There they go.
Now, as I mentioned previously, both fairing halves are brand new and are now making their way back down to Earth and will be recovered by our recovery vessel Doug today.
That's nuts, Shach. Unbelievable. There have been more Falcon 9 Block 5s launched after
It is T plus 4 minutes into today's mission.
Weird.
And in order to complete today's landing, the first stage has 2 more burns left. Next up is the entry burn, and that's where 3 of the Merlin 1D engines will reignite. This helps to slow the vehicle.
So why use Falcon 9 and not Heavy? Honestly, easy. Falcon 9's design has been stretched over time. They keep expanding the performance of Block 5 because they basically do trajectory optimization, hardware optimization. You launch it more, you understand more how the vehicle works, and you can squeeze more performance out of the thing. Falcon 9 is a heavy launch vehicle. A single stick Falcon 9 is a heavy launch vehicle at this point, which is a little bit absurd to think about. It's a heavy launch vehicle. A single stick Falcon 9 is technically in the same category as like Delta IV Heavy and Atlas 551, which is, that's impressive. That's really impressive. Falcon 9 can move 22.5 tons to low Earth orbit by itself. That's in a fully expendable configuration, but it can do it. It's a heavy vehicle, a heavy launch vehicle by definition, which is weird to think about.
Speed and altitude of each vehicle as well. And on your left-hand screen, you can see 2 of the 4 hypersonic grid fins that the first stage has. Those grid...
Euclid is only 2.1 tons at launch. Dendal, so? 2.1 tons to low Earth orbit would not be a big deal for Falcon 9, but you got to remember this is on an Earth-Sun L2 transfer. Not exactly a low performance mission.
And on your screen, you're getting a great view from the second
payload
stage.
Mass has to do with it, but
and
how
back
far
there
are
in
you
the
going?
Earth,
right?
Looking amazing in the background.
Dude, these
We're
cameras
just about
are
20 seconds away
upgraded.
from
They
the
upgraded
entry
the
burn
optics,
on
too.
the first stage
It's a
vehicle.
very beautiful picture. Look at how sharp that shot is. I just want to point out that this is a high definition shot that's being streamed to you from space. I mean, you can literally see the nuts and bolts on that motor, which is pretty freaking impressive.
Stage 1
pretty damn
FPS
impressive,
safe.
man. I love the future. The future's great. Oh, here's my favorite part. Supersonic
There you
retro
can see
propulsion.
the engines have reignited on the first stage.
As Falcon 9 gets further down into the atmosphere, it's going to start to experience re-entry heating. So SpaceX, not only to slow the booster down, but to protect it from re-entry, they fire the engines. Yeah, you heard that right. They're firing the engines to push the re-entry heating away from the vehicle. My favorite part. They don't fight fire with fire, they fight plasma with fire. Yeah, really, really good stuff. Supersonic
More burn
retro
for
propulsion.
the first stage vehicle. as it attempts to land on our drone ship, and that is the landing burn. It will just be a single engine, the Center E9 engine reigniting, and that is enough thrust to help slow down the vehicle to enable it to touch down on our drone ship.
Yeah.
Now, during the first stage landing burn, excuse me, the vehicle will be landing for its second time.
Stage 2 FTS is safe.
Oh, wow, it's a little windy up there. Oh,
the vehicle will be landing for its second time today.
Them upper level winds, though.
Just before the landing burn begins, we will also have SECO 1 on the second stage. That is second engine cutoff 1. That's where we'll shut down that MVAC engine on the second stage. This is the first of 2 burns for this mission.
All right, so now we should see the drone ship. The drone ship should be under the left grid fin. Should be down here somewhere. J-Shelf, 38 months. Okay, once the landing bird starts, they're going to start steering her in. That's solid oxygen coming off there, fellas. There we go. Landing burn has begun. There's the drone ship.
The MVAC engine has shut down, and the landing burn has begun on the first stage vehicle.
It's windy. Come on, baby. Landing leg deploy. Right about now.
Expected loss of signal, Cape. Nominal orbit insertion.
What an incredible clear view of Falcon 9 touching down on a shortfall of gravitas. This landing marks the second successful landing for this particular booster and marks our 200.
So you know what's cool? You could see the telemetry from the first stage is reading 0, 1, 0, 1, 0, 1. You know what that is? That's the drone ship rocking back and forth on the ocean. The telemetry, the sensors on the Falcon 9 are picking it up, which is funny. See? See, it's going 0 to 1, 0 to 1. That's the, after they landed, that's the drone ship rocking in the waves. Oh, what a shot, man. What a shot. It's so clean. Dude, they upgraded the second stage optics. I don't remember them being this crisp. That's really, really nice. Any opinions on the stubby MVAC? I hate it. I hate it, Space. I understand why it exists, but I hate it. Are the telemetry sensors on stage 1 at the top or the bottom? I'm not sure, Zeros. I don't have that information. They have a loss of signal through Bermuda here. Yeah, so somebody asked about if yeah, Varigor, we have a clean uninterrupted shot from the drone ship. The drone ship uses Starlink. Falcon 9 does not use Starlink. Why? Changing the antenna, believe it or not, changing the antennas on your spacecraft is about as hardcore of an engineering change as changing your rocket engines. That's a really big deal. Why? Well, there's that whole thing about being able to, you know, figure out where the rocket's going and whatnot, and if you can't get a good signal because you change the antenna, it might go where you don't want it to go. And rockets always have to have a good connection. If they, at least during the launching phase, if you lose connection during the launch phase, you got a big problem. Because that means if something goes wrong on the rocket and it goes where you don't want it to go, the signal that they would send a signal to terminate the vehicle, to abort the mission. And if you don't have a signal, you can't do that. Now, rockets like Falcon 9 have an automatic flight termination system, so it's not as big of a deal, but maintaining a connection during the ascent phase is really, 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 really important. And that's why Falcon 9 would not, they don't change the antennas. That's as crazy as changing an engine. It's a big change. Just keep using what works for now. Now, putting a Starlink antenna on a drone ship that's floating out in the ocean is a little more lax. That's not that big of a deal comparatively, right? So that's why the drone ships are, have the Starlink antennas on them, but Falcon 9 does not. It's also a ton of paperwork to change your antennas too. Just putting it out there. So, no, Duncan, it's an encrypted signal. Yeah, we know it's encrypted because somebody picked up on the second stage feeds at one point, and yeah, SpaceX encrypted the signal the next day. Raiden, what's up, buddy? 11-month resub. Did you see this? No, I don't know what that means, Forge. So, with that being said, guys, Starship has Starlink antennas integrated into its design because it's being developed. It's not already pre-existing. Does stage 1 usually come in that hot and burst the engines right before touchdown? Yeah, it was a little windy, Moose, so that landing was a little bit sketchier than what we usually have seen in the past. But yeah, that was fine. So right now they're in a parking orbit. This is a parking orbit at around well, we have a loss of signal, so notice that these numbers are not updating because they don't have a signal on it. Losing connection right now is not a big deal because the second stage has entered inertial guidance, meaning the onboard accelerometers, or well, they're called inertial measuring units. The onboard IMUs are using the last known connection point plus the acceleration of the vehicle to determine where its orbit is. So the onboard computers will know where it is, so it knows where it isn't. Now, once they get a reacquisition of signal, these should update. But the second stage is, and that's the reason why we're not seeing an onboard. SpaceX doesn't have a good connection. Now, it's funny because I was just saying, like, oh, you have to have a connection to the vehicle. It's vital. That's just during launch. When it's coasting like this, it's not that big of a deal. But we should get a reacquisition of signal here soon. And they're definitely going to want one during SES2 and SECO2. Because they're in a low Earth parking orbit. Basically, they wait to get into the right phasing, basically the right spot to get out to that L2, Earth Sun L2 point. But they're also right now putting it into a parking orbit is a good way to basically make sure if something does go wrong, if something went wrong at this point in the mission, the thing would just come back down. Like, it's a good abort contingency to go into a parking orbit first and then go where you want, not just do a direct descent to wherever the final destination in space is. You kind of want to get here first because this is a major milestone getting into orbit, right? And then do your transfer burn. But the crazy thing is that there's sometimes there are missions that call for a direct descent to a certain area, and those missions are definitely a lot more hardcore. Like, no parking orbit insertion going direct to GEO or direct to GTO or direct to L2 or something. Those missions are crazy high performance. How is that any different than what I said, Forge? I said it in 2 sentences, though. You typed a word salad in my chat. I don't think they get a signal from French Guiana unless the Europeans are letting them use a tracking station. But the numbers still haven't updated, so I don't think they have it. French Guiana is up here somewhere. It's like right there. So what does Mission Control do right now? Check that everything is working? Yeah, that's what flight controllers do. They're monitoring the telemetry on top of the computers on board Falcon 9 monitoring the telemetry. They basically wait until they get a reacquisition of signal. Hypothetically, could Falcon Heavy have launched James Webb? I think that James Webb was, I don't think it would have fit in the fairing. Maybe Falcon Heavy with its extended fairing, yes, but I don't think it would have fit inside of Falcon's fairing. But I might be mistaken. I just got back at CEJ Online. Yay! I know it's a launch, but is there any possibility of Minecraft Saturday? I'm sorry, Galactic. There is not. Oh, there we go. We got a reacquisition of signal. There isn't, man. I have stuff to do today. I have people coming over for the 4th of July, and I have to take care of my house. Dude. A house requires an insane amount of upkeep. Not insane. It's just something you have to do all the time. But enough about me. Let's talk about the mission.
If you're just joining us, liftoff occurred at 11:12 a.m. Eastern Time from Space Launch Complex 40 in Florida. After liftoff, we also had successful main engine cutoff, stage separation, ignition and shutdown of the second stage, fairing separation, and first stage landing. Now, coming up shortly, we'll have our second burn of our MVAC engine on stage 2 prior to payload deploy, which basically means that we will relight and shut down the second stage engine for a second and last time. Now, SES2 is coming up here in just about 10 seconds or so.
Wow.
And SES2
Look at all the
is
solid
second stage
oxygen that
engine
built up.
start 2.
So the reason why we have a lot of solid
down
oxygen
that
buildup
MVAC
here is
engine.
because they're venting the engine down. They're repriming it to get Ooh, the encoder took a dump right there. They were repriming the engine, and that's a good reignition
You
there.
can see on your screen that the MVAC
What a
has
shot! Look at how crisp
reignited.
it is, man.
Again,
Oh,
this burn will last
You can
about
see all the
90
different types of
seconds,
cloud cover. That's
and
nuts,
it will be the
dude.
last
I can't
burn
believe
of
how
stage
crisp
2
this shot
before we
is.
deploy the payload.
Yeah, see, some of the solid oxygen gets stuck on the film cooling manifold here. This piece right here, guys, that manifold is designed to take the
As a
fuel
reminder,
pump's
the
exhaust and
Euclid
pump it through the
payload is
nozzle
still
to keep the
attached
nozzle
to
cool.
the second stage at this.
If you notice, right where the manifold is, the engine is nice and cool. But as you get further down the nozzle, it's getting a lot warmer. Don't lick it. Also, we're getting some oscillations from the M1 vac nozzle right there. But that's
we
normal.
should have SECO 2 coming
These
up here
oscillations
in
are
a few
normal.
seconds. That is second stage engine cutoff.
Yeah,
and
isn't
will
it
be the
crazy?
conclusion of the
32,000
second
kilometers
and
an hour,
final
now
burn for this
36.
mission.
No big deal. It's 25,000 miles an hour, whatever. That is not a stubby MVAC. No, it's not. Do you do Israel Jackson and Roscosmos
MVAC
launch?
shutdown.
I try to cover what I can, Space, yeah. Mostly American stuff because time zones, but yeah. If it's high profile from Japan, we will watch it, and the Europeans too.
We've just had
Israel, if we
SECO
have the
2
time.
Nominal orbit insertion.
We have a good call
There's
for
that
nominal
call out.
orbit insertion.
We just had
That's
SECO
good
2
transfer.
and confirmation of good orbit. So with successful second engine start and cutoff, we'll join you live to cover payload deployment
better than
in about
80%
20
of
minutes.
streamers.
So we'll see you in a few.
Wrecked. All right, so the next step here is deployment here, which should be happening relatively soon. Yeah, Crash, I want to play Derail, but I can't. I have normie stuff to do, dudes. I'm not even kidding. Like, taking care of a house is a lot of work. It needs upkeep every weekend, which is... Don't get me wrong, I knew it needed to be done, but man, that's why I had to switch to taking Saturday, Sunday off so Brimo and I could do the work together. I'm not even kidding. What is that line crashing into the ocean for? That is the first stage ballistic trajectory, if I'm looking at that right. But that's where the first stage would have gone had, I think. Let me back it up. Either that or it's the next orbit. No, okay, yeah, no, I'm wrong. See, the first stage ballistic trajectory is over here. That is that's the next orbit when it comes around. But the thing is that it's not going to, yeah, let's see. Yeah, see, right here. So, okay, this is actually really cool. That's a good eye latte. What this is it's the trajectory post-transfer of the next orbit for the second stage. So what does that mean? When the second stage comes back down, it's going to burn up. Basically, it's just good disposal. Don't get me wrong, it's not going to burn up and crash into Sao Paulo or something. That's not happening. It will obliterate that thing coming back from Earth Sun L2, if any. But actually, now that I'm thinking about where this thing is going, we might not be seeing that second stage for a long time. Right, Rogue? Like, yeah, it takes a second, man. It takes a lot of work. Israel copyright claim Matt Lone's video a few times. Nice. Feel on that one, going to Home Depot after the launch is over. Dude, me too. Chris, me too. Oh, it's so screwed up. Side note, the ship Starship quick disconnect is back and being mounted. Nice. Anyway, I'm kind of rambling. I'm pretty sure that's second stage trajectory after it comes back down, but I'm not sure if the second stage is coming back. It might escape Earth's... We're at escape velocity here. I know we're at escape velocity because the satellite is going beyond Earth's orbit. I think that's what that is, Latte, but yeah, I'm pretty sure. Pretty sure. I thought it was a ballistic trajectory from the first stage, but it's not. I was wrong. That theme song lives rent-free in your head. Dung, 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 dung. So what orbit would the satellite be at? Euclid is going to Earth, Sun, L2. Lagrangian point L2 between the Earth and the... Or not between the Earth and the Sun. It's outside of the Earth and the Sun, Reveral. It's where James Webb is. Yeah, they're going to be just chilling out there. Yep. Actually, Euclid is supplemental to James Webb. The Europeans designed Euclid to kind of work with James Webb. So both the satellites will be out there not working in tandem, but one will be looking for one thing out there and the other one will be looking for another thing out there. It's just part of NASA and the ESA's cooperation in space. They're supplementary to each other, which is actually really cool. Really smart architecture. Like Euclid is designed to look for dark matter and dark energy, and James Webb is an infrared telescope. And they'll work in tandem. Think about it like having two different types of cameras out there, right? Like a wide angle camera and like a fisheye lens camera or something. Like you have two different satellites out there, two different telescopes that are taking pictures of the same stuff, but one has a different lens almost. Now don't get me wrong, it's not like they could take parts off Euclid and put them on James Webb. A little bit different. But they do take pictures of basically the same things, but one's looking for one thing, the other's looking for another. It's outside of Earth Sun L2 is outside. Cohabitation on L2. Yep. Mm-hmm. Well, they could tape them together. I don't want that. My three favorite words: cooperation in space. Damn right, Vex. Why not? No. So this L2 point moves with Earth's orbit. It does this. So that one in the center, and if we're talking Earth Sun, the Sun is in the center right there, and Earth is that. They're basically...
Expected loss of signal.
They have a loss of signal right there. So think about it like this. Once again, I understand for the pedants in chat, I understand that it doesn't actually work like this, but a good way to think about this Lagrangian points are they're neutral points in gravity between celestial bodies in space. Now, if that means nothing to you, I just said a bunch of words and you're like... Think about them kind of like a tide pool. It's a space tide pool of gravity. You could just kind of get stuck in between some of these points. Now, once again, I understand for the people that love picking apart my analogies, they're out there. I know you're out there. I see you. You do need to kind of stay. You need to use thrusters. These not a lot of these places are stable. But what James Webb and Euclid will do is basically orbit around L2. They're stuck in the tide pool. Tide pool is just a visualization. It's just a visualization for kind of how it works. But there are these neutral points in gravity, and they're kind of like tide pools. And the satellites kind of just sit there and orbit around. It gets stuck in the tide pool, so to speak. It's really wild stuff. Does KSP support Lagrangian points? No. The KSP, dude, the type of math that you would need to do Lagrangian points in KSP would quite literally fry your processor. So you don't actually move either. Yeah, they kind of just orbit around it. I say orbit around it. That's not even the right way to say it, but that's the best way to... Like a tide pool is the best type of visualization for what it's actually doing. Are they stuck in this tide pool forever? No. They need thrusters. Duncan, they need thrusters to stay in there. You know, think about it if, you have water flowing down a river and there's a little tide pool. Stuff does get stuck in the tide pool, but eventually it'll keep going. Same idea. That's what's called a non stable. It's not a stable orbit. They do need to make slight modifications on the thrusters to stay stuck there. Yeah, some Lagrangian points between celestial bodies are more stable than others. I mean, I'll show you that picture, but again, I bet you can guess which one is more stable. The one that's on a flatter plane of gravity, that, like L4 and L5, L4, L5, and L3, much more stable. But L2 in this particular case is really good because Earth doesn't get in the way. I had previously said that it eclipses the sun. That's not exactly right. That was not right. I was wrong. I was thinking of Earth Moon L1, which is, or EML2, Earth Moon L2, which is totally different. But yeah, they put the satellites out here so Earth doesn't get in the way of the shot. Why is there only L1 through L5? Those are all the neutral gravitational points, between two celestial bodies. You could have a 3 celestial body system with Lagrangian points, and there actually would be more. So what would be a 3 celestial body system? Think a binary star, where you have 2 suns. So if you're a Star Wars fan, Tatooine is orbiting around a binary star. There's 2 suns, which is why Tatooine is a desert in Star Wars, right? 2 suns that have a planet orbiting around both suns would have more Lagrangian points. That's a 3-body system. Yeah, there would be more. There would be like L30 or something. Pretty cool. But traditionally, between a 2 celestial body system, so like Earth, Sun, Earth, Moon, there's 5 Lagrangian points. There's 5 neutral points in gravity. What's crazy is, guys, is that the outer, like, okay, so you want some planetary physics stuff. Jupiter has insanely large Lagrangian points, so the solar Jovian Lagrangian points actually have a bunch of asteroids stuck in them. You know how people always say, oh, well, if we go out to the asteroids, we'll have plenty of materials out there, boy. That's what they're talking about. The asteroid belt, a lot of the asteroid belt is kind of stuck in these neutral points of gravity, which is crazy. I'm pretty sure, if I'm remembering right, the Trojan asteroids are out there, and they're kind of stuck in these Lagrangian points. So as Jupiter flies by the asteroid belt, right, or, the asteroid belt's not like perfectly uniform. When it gets near it, it'll pull stuff towards it, and stuff gets stuck in those tide pools, which is actually really cool. I think that's really neat. Space is not clean. It is not a clean place. That is the first thing that I try to tell everybody. It is not clean. There's all kinds of crap up there. Rocks, ice, dirt. It ain't clean. There's all kinds of stuff. Protoss. Assa de Templari. I don't know if you'd have some type of stable Lagrangian point 1D between like Earth, Sun, and Venus. I don't think that's how that works, but that's kind of getting a little bit beyond my knowledge of orbital mechanics. Hey Duncan, thanks for the Prime sub, dude. Thanks for the Prime sub, dude. I think I said it right. I need more coffee, man. Chat, you must construct additional pylons. Truck tire. A Tesla. There is a Tesla up there floating around. The Tesla's floating around in what's called an eccentric heliocentric orbit, with aphelion near Earth and perihelion near Mars. Flip those. Aphelions near Mars, perihelions near Earth. What that means in plain English is that it's some weird orbit that's between Earth and Mars. They launched it at Mars, but the problem with that Falcon Heavy test flight is that they weren't in a transfer window to launch to Mars, so they basically pointed Falcon Heavy at Mars and launched it. The problem is, if you point at where it is right now, you're not going to get to it, because that's not where it's going to be. In orbital mechanics, you've got to put yourself on an orbit where the planet's going to be by the time you get there. So if you just point at Mars and hit the go button, unless you're planning on going warp speed, Mr. Sulu, you're gonna miss. You're not getting there. require more monoprop gas. No problem, Boston. Just trying to understand. Yeah. You know what's good for understanding, man? If you get more frickin' dunks. Get more frickin' dunks, put dunks in your frickin' cup, and you'll start understanding it better. Okay? I am not sponsored. It's frickin' wicked smart. My boy's wicked smart guy. You must construct additional pylons to understand space-time theory. Nice. You drinking dunks right now? That a girl. Nikita, that's awesome. I saw the name of the next Electron launch is Electron. Baby, come back. So they're going to try and catch it. I'm actually a little bit out of the loop space with current launches, dude, because I've been away, and I'm actually going to be away a little bit next week too. But I would assume that because of the name, that probably is indicative of the mission, but it's better to know, right? Use delivered donuts for Duncan. I can't eat them anymore after how many you eat. Really, Patcher? Oh my goodness. You hook Geek Nation on the dunk. Dunks is the best, man. Never to have a normal broadcast week again, huh? Actually, after this week, Hellfish. Actually, after this week, dude, no days off. Except for the weekends. Until Labor Day, man. I really have been... Dude, you have no idea. It's been pissing me off how much time how much I've been away from the stream. It's really pissing me off. Like I know why, don't get me wrong. I understand, like, come on, it's a wedding and 4th of July and stuff. I always take the first week of July off anyway, but dude, it doesn't mean that it's not weighing on me. I'm like, oh, I need to get back to work, man. So what does a proper Bostonian 4th of July food consist of? Hot dogs and burgers, my dude. Hot dogs, burgers, beer, and fireworks. Don't eat the fireworks. Wait, he never did. You're half right. Where can I get the best Boston cream in Boston? I mean, Dunks have pretty good Boston cream, but if you, Dino sign, the key with Dunkin' Donuts, dude, is to go early. Go early in the morning when the donuts get delivered fresh, and they're pretty friggin' good. But there are, with that being said, there are a bunch of small mom-and-pop donut shops around. Sausages and steaks, you could do that too. Wawa donuts are top notch. Not gonna argue with that one. Victory Moms in Newport, cool. Smoke a brisket. Now we're talking. Alright, guys. We should be coming up on deploy here very soon. Mike's pastries are good, DeBomb. Yeah. I mean, they probably have a pretty good Boston cream in there, but Mike's is more known for its cannoli. The cannoli is... Does this adequately explain? The cannoli is... Beer battered brats. Now we're talking, man. Yeah, exactly, AP. The cannoli from Mike's is this. The what now? What? Drummer, don't tell me you don't know what cannoli is. You don't know what cannoli is? What? I'm judging, and I'm a terrible person for doing it, but I'm judging. You don't know who Obi-Wan Cannoli is? What's wrong with you? Oh, confused over what a biscuit is. No. So a cannoli is an Italian pastry, dude. It's usually had for dessert. It's frost, like the really plain Jane way of saying it. It's not exactly this, but it's frosting inside of like a kind of it's kind of like a biscuit that's shaped like a tube with frosting inside of it, I guess would be the right way to say it, but it's not. It's a pizzelle with frosting inside of it. But that saying that probably doesn't help. Biscuit tube. What is a biscuit in this context? Waffle. Yeah, kind of like a waffle cone. Yeah, kind of like that. I got your tube right here. Cannoli is good, man. It's delicious. Yeah. Thicker rolled crepe with buttercream. I guess. Yeah, da bomb's a good way to say it. Yeah. It's a fried biscuit with ricotta cheese. It's delicious, man. Cannolis are amazing. You know what? I'm probably going to get some. I know we hopped off the space talk for a bit, but there was this video I saw where it showed the gravitational relationship between Jupiter and the Sun. Technically, Jupiter doesn't orbit the Sun, since they both pull on each other. Obviously, the Sun pulls Jupiter to more effect because of the physics. This is wicked insane. No, it orbits. It orbits. I'm pretty sure. Gravitational bodies influence each other, sure. Yeah, of course. Every action has an equal and opposite reaction. So the Sun is pulling on the Earth with the same amount of force that the Earth is pulling on the Sun, but that's correlated to their mass. Force equals mass times acceleration, right? So, but since the Sun has a lot more mass, it pulls stuff in. Stars are very dense, like me. Oh, you're talking about Barry centers. Yeah, no, you're right. Yeah, that's correct. Yeah, Joe, if that's what he's talking about a Barry center. Yeah. Yeah, that's correct. Yeah. Jupiter doesn't orbit directly around the Sun. Yeah, absolutely. Yep. See, like I told you, I'm dense. Yeah, if you're talking about Barry centers, Lumen, yeah, that's wild stuff, right? Oh, we got a reacquisition of signal there. Yep, slightly off center. Yeah, nothing is perfect up there. It's all weeble wobbly, you know? Dude, that reminds me of I was hanging out with my neighbors after the stream last night, and the topic of space came up, and they all looked at me and they're like, EJ, you know about space? And I'm like, oh no. What do you want to know? And the conversation ended up with me having to describe a solar maximum and what solar maximum does and how orbits precess and whatnot, and yeah, that didn't go very well. It didn't go very well, dude. They were like, wait a minute. Let's watch the satellite deploy. I'll tell you, this story's weird.
And dark energy, which combined is known to make up 95% of the universe as we know it, and create an unmatched 3D map of the universe with time as the third dimension by observing billions of galaxies across 10 billion years of cosmic time across more than a third of the sky. The deployment is coming up here in just a few seconds.
Euclid spacecraft separation confirmed.
Go, Euclid, go!
And there you can see the Euclid payload drifting away from Falcon 9's
Bon
second
voyage.
stage. With that confirmation, we'll bring today's broadcast to a close.
Good.
Today's mission marked
Good. Perfect.
SpaceX's 243rd overall mission to date and 44th mission of this year.
It's
we want to thank the European
insanely
Space
high
Agency
performance
for
mission,
entrusting
Rogue.
us with today's mission,
Yeah.
and all of you for joining us. If you're interested in following the Euclid mission further, tune into youtube.com/ESA for more. And be on the lookout for the first images from the Euclid telescope later this fall. Thanks for tuning in, and we'll see you again soon.
All right. Cool. Excellent. Anyway, so that was the Euclid launch. That is a really high performance mission for Falcon 9. That's part of the reason why they didn't have stubby nozzle on there. Play some KSP. Space, unfortunately, I can't today. I have real life stuff and 4th of July and my birthday and stuff coming up right after that. So I'll be back. I might be back on Wednesday, or Thursday. It's going to be either one. So NSF article said this telescope is around 1.5 billion. It's actually a pretty good price for a space telescope. Space telescopes are expensive. Happy birthday, thanks, Jim. So, yeah, that conversation about explaining solar maximum, they looked at me, they go, "Why is it getting so hot?" And I'm like, climate change has a lot to do with it, but there's also solar maximums and stuff. So I explained solar maximum and how it works. Like, basically, the short answer is that we get closer to the sun every like 10 to 15 years because of all these wobbly orbits going on, right? And they were like, "Oh, so climate change is bullcrap." I'm like, no, oh no. Oh gosh. Hey, thanks for all the birthday wishes, guys. I appreciate it. Thank you. I'm like, no. Why did I say that? No. Oh, I'm like, I don't want to talk about space right now. Just let me drink beer, man. How did you steer away from that? I said no. The weird solar maximum has a little bit to do with it, but the point that I was trying to get at is this is not just one thing. I mean, the climate does change. It happens. That absolutely does, and we're probably doing something to it. just putting it out there. Like, I was trying to illustrate is that it's a complicated system. There's a bunch of stuff. It's not just one thing, right? And yeah, because we were all sitting around a fire drinking beer, it's like, oh, it's bullcrap. Frick those guys. I'm like, oh no. And then the subject changed, so we're good. We started talking. I changed the subject to baseball. I was like, yeah, that's cool. But did you see that play? And they're like, oh yeah, the play. I'm like, yeah. Plot twist. They're watching right now. I'm like, oh no. You're gonna have to do that at some point. It was a conversation over beer and a campfire. I looked. I don't think anybody remembered that conversation. I thought you were one for blunt honesty. Oh my goodness. Anyway, guys, I have stuff to do this weekend, so I'm not gonna see you until after the 4th. So everybody that celebrates it, have a good 4th of July, and all my Canadians, have a very good Independence Day today. May your afternoon be filled with Molson and Labatt Blue and poutine and maple syrup. So, yeah, thank you very much. Yeah, I did, Hibbit. I saw it. Yep. So, thank you very much for watching. Guys, I gotta head out. I gotta go mow the damn lawn, boy, I tell you what. So, once again, I probably will be back on Thursday. If not, maybe Wednesday. It really depends. If I do stream on Wednesday, it's gonna be a shorter stream. So, yeah. And then, after this coming week, It should be back to the regular schedule. Should be. We'll see what happens. But yeah, I don't like the amount of time I've been away. It's really not cool. Not cool. But anyway, thank you very much for watching. Have a good rest of your weekend. Happy 4th to my American friends. Happy 1st to the Canadian friends. And everybody else, have a good weekend. I'll see you guys. Thank you very much for watching. I was about to say good night, but it's noontime where I'm at. For the European, good night. Yeah, all right, it works. All right, I'll see you later. Thank you.